Okay, we're going to go ahead and review the limit laws from Calc 1. So we're going to start off by assuming that A sub n and B sub n are convergent sequences. So that means we know that they converge to a finite number, and we're going to represent that with the capital letter L and the capital letter M, respectively. Okay, so the first limit law is if we're adding or subtracting two functions, then we can split them up and we can take the limit of each one individually and then either add or subtract them as appropriate. Same thing applies if we're multiplying two functions together. So if those functions individually were convergent, then we can multiply their limits together. Same thing works for division. Okay, and then we have the rule where if C is a constant, you can pull the constant out in front. Evaluate what the sequence is doing. So it's here it's converging to the letter L, and so we can multiply C times L. All right, I'm going to add one more limit law in here that you may or may not have learned in Calc 1. So if f of x, so if a function is continuous, and the limit of a sequence as n goes to infinity is L, then we know that we can take the limit as n goes to infinity of f of a sub n. So in other words, we're going to take our function and we're going to put our sequence in it. And what we can do then is we can actually pull the limit inside of the function. So I have f of the limit as n goes to infinity of a sub n, which is going to be equal to f of that limit, which is L. So f of L. Okay, so we're going to go ahead and try these rules out down below. So the first one I have is the sequence is cosine of 5 over n. So if I write my limit as n goes to infinity of cosine of 5 over n, that's going to be equal to cosine of the limit as n goes to infinity of 5 over n. Okay, and we know what that does. That's basically 5 divided by the federal debt. So this is going to 0. So this is cosine of 0. We know cosine of 0 is equal to 1. Okay, so here we have a convergent sequence that converges to 1. All right, the next one is arctan. So I'm looking at the limit as n goes to infinity of arctan of 2n. So if I look at bringing this limit inside, this is basically just going to infinity. So I need to know, what does arctan do as n gets really, really big? So if we remember that the graph of arctan is going to look something like this. Okay, it's going to have an asymptote there at pi over 2. Okay, so we know that that sequence has a limit of pi over 2. All right, and then this last one, so I have ln of n plus 1 minus ln of n. So in order to do this one, I'm actually going to use the law of logs to combine this. So since there's a subtraction sign there, this is really ln of n plus 1 over n. Okay, so use those limit laws to combine, and now I can apply the limit. So the limit as n goes to infinity of ln of n plus 1 over n, which is equal to the natural log of the limit as n goes to infinity of n plus 1 over n. Okay, so I was able to bring that limit inside. This is going to 1, so n plus 1 over n. If I take that limit as n goes to infinity, that goes to 1. And so I'm looking at the natural log of 1, which is equal to 0. Okie dokie.